Okay, I have an answer, but I'm very much not sure.
Can you explain your solution? No problem. Can you explain your solution to check?
Okay, so basically, I changed the 1/3, so then you get n times log 20 cube root of n.
N times log 20 of cube root of n. Okay, then what?
And then okay, this is a step which I don't think I did right, and I think I got this part wrong. I squared everything.
Okay, you raise the power of 2, so then what?
I squared everything because you know that the square root of n can't be a negative number, and the other side is bigger, so the sign doesn't change.
So then if you raise the power of 2, left-hand side would be what?
Log 26 root of n.
2. Can you say it again? It would be what? N to the power of what?
Well, it would be n to the power of 2 times log 20 cube root of n.
Exactly. Then what?
And then I put the 2 inside. So then I got n to the power of log 26 root of n.
20 what?
6 root of n.
No, look, it was in the fraction that you said cube root, but here it is in not. 3 was in the denominator. Here 2 is in the numerator.
Oh no. Okay.
So it would be what?
It will be. Wait, I did this part wrong. It will be n times log n square root of n.
Cube root of n squared, right? Because look, it is when it is 2, it is a squared. When it is 1/3 to the power of 1/3, which is cube root, right? In general, if you have, for example, x times log a to the b, it is log b of a to the power of x. Okay?
Yeah.
Log a to the x to the base b. So here, when we have 1/3, if you raise the power of 1/3, it's cube root. If it is 2, the square of this. Okay? Now we have this. Okay, want to try again? Or want... After this, we can say what?
Well, after this, you can say that log 20 cube root of n squared has to be bigger than 1.
Yes, because look, n is positive. N is not 1. Why n is not 1?
Because otherwise 1 won't be bigger than 1.
Yes, because then 1 to the power of 0 is equal to 1. It's not greater than. N is at least 2. And when this base is at least 2, let me tell you this.
Yeah.
When you have something, for example, b to the power of x, it is increasing if b is greater than 1. Okay?
Yeah.
Now here, n to the power of something, we know it is an increasing function. So when it is greater than this, means the powers of this is greater than this one, and then
so therefore you get log 20 cube root of n squared must be bigger than 1, which we have, and then I got cube root of n squared must be bigger than 20.
Exactly, because again 20 is greater than 1. It is
and then
increasing.
You get n squared must be bigger than 20 cubed.
N squared? No. N squared and 20 cubed. Not cube root of 20. Yes. Then what?
So n has to be bigger than square root of 20 cubed.
20 cubed is what?
20 cubed is 8,000.
Do you know how I told you the algorithm to calculate the square root?
You did, but I can calculate it. Well, just...
Okay, so calculate. So it says find minimum n. It says how many positive integers and don't satisfy the inequality.
Yeah.
Okay, so
it's basically how many positive integers n is smaller than the square root of 8,000.
Smaller than equal, yes, but because it is not perfect square, yes, smaller. So calculate the answer of this problem.
Okay. So it's 89.
Okay. So let me tell you how you can calculate quickly again 8,000, square root of 8,000. We can say what? We can say 998864, right? 16.
Yeah.
Then here 16. Obviously, it's 9 works because it is around 10. So 9 times 9, 81. We have 8. 9 times 6, 54 plus 8, 62. We have 6, 15. It works. So it's 89 point something. Okay. So n
How
is
did you
greater
get to 9?
because it is 160 something times something, right? I know 160 times 10 is 16,000, right? 1600. Agreed?
Yeah.
So because it is 160 something times something, it is around 10, but usually, always, it's a one-digit number. So I've checked first 9. If 9 was greater, I would check 8, okay? You should check the maximum possible. This is
Because I just
89.
did.
What?
I just calculated that it was between 80 and 90, and then that it was bigger than 85, and then I just tried.
Because for example,
Tweak it.
sometimes you have to calculate with one decimal digit. Then you can add 2 zeros and continue this approach. This approach is so much useful. Try to understood how I calculated this.
Yeah.
Use, for example, some other numbers, 4-digit, 5-digit numbers, and then calculate this and check it with your calculator. That is your calculation correct. Also, you can calculate with one decimal digit, 2 decimal digits, and so on. Okay.
So is the answer 89?
N should be at least 90, so 89 answers are bad. Good job.
What type of challenge is this from?
It is for SMO. But in all problems, it was related to logarithm, okay? If you have any logarithm problem in BMO, this, you should use exactly same approaches, also in AME, okay?
When you say, what year is senior?
Junior, senior, open section. Junior section, open section, senior section. It is not similar to BMO that, for example, we have SMC. SMC is the highest one, right?
For challenges, yeah.
For challenges for UK. We have junior, intermediate. Let me write junior, intermediate, senior, right?
Yeah.
It is for UKMT, for challenges. For SMO, for Singapore. We have junior, senior, open section. So the difficulty of open is related to this senior, intermediate, junior, okay? Okay, but the problems are harder than challenges, okay? For the years, they are related to each other, but if I want to say difficulty of these two things are similar. This one and, for example, senior of UKMT are similar.
So is this easier-ish than BMO or same level?
In general, SMOs are harder than UKMT, but easier than BMO. The relationship like this.
Okay.
Challenges, the difficulty, then we can say these SMO problems, then BMO one, okay? Okay, so this one, and let me check something with you. I told you there are lots of things here in logarithm and the things that are important. When b is greater than 1, we have this. When b is less than 1, it is decreasing. But b should be less than 1 and greater than what? It is b to the x. Greater than what?
B should be greater than 0.
Exactly. Because when you have negative number, for example, negative 1 to the power of root 2, because we know negative 1 to the power of even numbers is 1, negative 1 to the power of odd numbers is negative 1, right?
Yeah.
So when we have root 2 something like that, that's the reason they define it for positive numbers, be positive, right?
Yeah.
And another thing that is important is that it is increasing, it is decreasing, and we can also relate it to log. For log, if we have log b of x, for 1 also, for 1 it would be this, 1 to the power of x. Okay, they usually don't define. For b less than 1, b greater than 1. For log b of x, can you tell me the graph would be what?
Log b of x would be
Let me tell you something. Do you know inverse of a function is what?
like the opposite of that.
Yes, for example, input, you should switch inputs and outputs, okay? For example, suppose our function f of x is 2x, okay? It means that when you, for example, when input is 1, output is 2, right?
Yeah.
Now, if I want to reverse it, I want to, for example, give 2 and get 1. Or here, as you can see, when you give x, you get 2x, right? Here I want to define a function that when I give 2x, I get x. So g of x is inverse of this. Is what?
X over 2.
Exactly. So these two functions are inverse of each other, right? And when two functions are inverse of each other, f of g of x is x. Agreed? Because g of x is x over 2, f of x is 2 times that. Also, g of f of x is x. And we call g is f inverse of x, okay? We call like this. And usually when we have g and f, if we draw them, they will be symmetric with respect to y is equal to x. Let me tell you why here. So, I want to say, for example, f and g, and in general, these functions are symmetric with respect to this line. This line is y is equal to x, okay? So let's check it here. F of x was 2x, right?
Yeah.
So for 0 it is 0, 2x. Let me draw this. It is 2x, 60 degree. Do you agree x over 2 is the angle 30 if we draw? So as you can see, it is g of x is x over 2. It is f of x is 2x. Do you agree that they are symmetric with respect to this line? You can say this angle is 30, this angle is, let me tell you, this angle is 30 because you know that this part is when it is x over 2, it is, for example, 5, the 1 over 2. Oh, no, related to tangent. So you can say it is alpha, okay?
Yeah.
Now that you know this, I want to tell you that logarithm and this function are inverse of each other. It means what? Suppose f of x, for example, is 2 to the power of x, okay? And g of x is log x to the base 2. If bases are equal, they are inverse of each other.
Yeah.
Let's check. For example, when you give 3 as an input for f of x, then you get what as an output?
You can get 8.
Wait. What about g?
And you can input 8 and
When you
it's
give 8, output is what?
3.
3. So, and also we can say f of g of x is x. So let's check it. G of x is log x to the base 2. F is what? F is 2 to the power of the thing inside. So this one is what?
That one is x.
Yes, by the definition of logarithm. Also, g of f of x is the same thing. F of x is 2 to the power of x. G of that is log. 2 to the power of x to the base 2. It is what?
It will be f.
Exactly. And if you want to draw this function, we know 2 to the power of x is what, right? It is something like this.
Also, you know,
yes. Let me this one a bit better. So it would be 1. It would be something like this, okay?
Right.
And if you want to find, it is 2 to the power of x. If you want to find log 2 of x, we should reflect it about y is equal to x. So this one goes to here, and this line goes to this part. It would be something like this. Okay? Understood?
Right. Okay, yeah.
Okay, it is increasing because 2. And in general, for b to the x, if b is, let me check this with you. Suppose it is b. B should have what condition to be like this?
B needs to be positive.
Greater than 1.
Greater than 1.
Okay. Because look, 2 squared, 2 cubed, it will be larger and larger. But if it is, for example, 1/2 to the power of 3, 4, it will be smaller and smaller. It cannot be like this, right?
Yep.
Okay, so the function of log is this, and let me tell you the function of log when b is less than 1 and greater than 0. So we said it is decreasing. Let me again draw y is equal to x to reflect this. So it would be what? It would be something like this. Okay?
Yeah.
Let me draw a bit better on this part. Or a bit. Now, if you want to, it is, for example, b to the x, which b is from 0 to 1. Now it is 1. It is also 1. So if you want to draw log, it is decreasing. It will be something like this. This. Okay, it is log. b of x when b is from 0 to 1. Okay? Okay?
Yeah.
Understood?
Yeah.
So